Okay, so this is the continuation of the EDEXCEL mock exam. We did questions 1 to 7 in part 1, and we had a look at question 8, and I promised I'd make a video for the remaining questions 8 to 12. So, this one is about density. It's to do with a hailstone, and hailstones are, as many of you will know, icy raindrops, icy particles that come out of the sky. So they want you to describe how to determine the density of a hailstone. So obviously you will need to use density equals mass over volume. And there's multiple ways of getting the 4 marks for this answer to do with clarity of communication. So once again, I'm going to highlight keywords, so hopefully you'll see it says that you have to assume that the hailstones are spherical. Okay, so if they're spherical, you need to know what the volume of a sphere is, so you would calculate the volume using V equals 4/3 pi r cubed. Okay, so first of all, you need to be able to use the density equation, which itself will give you 1 mark. You have to measure the mass. They want you to be specific. How do you measure mass? You use the mass balance. Okay, you can just put electronic balance, mass balance. Okay, then you need to be able to calculate the volume with the equation. You obviously need to know the radius, yeah, because everything else is a constant in that equation. To know the radius, you have to measure the diameter, yeah. You can measure diameter using calipers or a micrometer, which is accurate to 0.01 millimeters, or if you set a ruler and you could try to work it out with a ruler, obviously the ruler is less accurate. Calipers actually hold the 2 sides. So these are the main ways of getting the marks. They would give marks if you add further detail, for example, and you miss one of the points, like take repeat readings and averaging, or take readings at several different orientations, which is a common question in physics, because it may not be perfectly spherical, but we're assuming it is. So you don't have to do those. So the ones I've highlighted would easily make up your 4 marks. Okay. Now they're actually making you put the real numbers in, or numbers that they've given you. The mean volume, they've given you the volume as being in centimeters cubed, 1.1 centimeters cubed. I always like to write the letters next to the numbers given to help you understand what I'm doing. The mass is measured to be 0.94 grams. So you basically have to just show that you can use the density equation. So the density, yeah, of a hailstone is given by mass over volume. Yeah, so once you put it into this equation, put the numbers in, if you use multiple decimal places, it'll be approximately this, 0.84545, but you only need to quote it to the same number of significant figures as the data given. So there's 2 significant figures here, 2 significant figures there, so you just need to put as 0.85. But they want the units, so don't forget that you're using grams and centimeters cubed. Okay, the next part of the question is about convection currents. So they want you to know that hailstones can be lifted to the tops of the clouds. That's how they get cold. That's probably why they freeze, because the top of the cloud is going to be much cooler than near the warm ground. So the warm ground is the source of your heat. Okay, so it says a diagram shows the movement of the hailstones. So this is showing how warm air will rise. Okay, so it wants you to suggest how hailstones are lifted to the top of the clouds by convection. Okay, so you've got to say what you know about convection, that warm air rises, yeah, and warm air is heated by the ground, so I've just put from the ground, and warm air expands in the process of heating up. The molecules spread out more, so they become less dense. As it expands, therefore you say the warm air becomes less dense. Don't just put it if you haven't clarified clearly that you know that it stands for warm air. So warm air becomes less dense than cold air, and in this way a convection current is set up. Cold air will sink, warm air will rise. These are the main points I've listed. As long as you've got 2 of these 4 listed in what I've written, you will get the marks. The next question is in a similar topic, solids, liquids and gases. This time we're talking about the kinetic theory gases. So the diagram shows an empty metal container, yeah, with a hole here. It has a hole in the top, it says. They want you to describe, so how air molecules, yeah, so molecules that make up air, inside the container exert pressure, yeah, how? On the inner walls. So the inner walls are obviously the inside of the container. Well, this kinetic theory of gases is molecules moving randomly, okay? When they collide, this is the point you need to make, collisions with the walls. Collisions produce forces, yeah? So the collisions, each of these microscopic collisions produces a continuous stream of forces on the walls. They bounce off the walls, and that change in momentum actually is the force per unit area. Yes, so when you divide that all the microscopic forces by the area of the walls, that's what pressure is. Pressure mathematically is the sum of all the forces divided by the area microscopically. Okay, and that's how you describe through the kinetic theory gases how pressure is exerted from microscopic collisions. It then says the container is heated for a long time. They're specifying. Explain, this time it's explain rather than describe, so it's a higher levels of science. What happens to the number of air molecules in the container? Okay, so remember the container has a hole at the top. So an increase in temperature, so any from this list will get you the mark. The bracketed are connected points. So increase in temperature increases the speed of the molecules. Higher speed or higher kinetic energy increases the chance of molecules escaping through the top, the hole, yeah? So basically once you realize that increased energy increases the chances of molecules escaping, so it's then you have to put, therefore the number of molecules will decrease, okay? So this critical thinking, you're basically working out problem solving. Part C then is opposite. They place a lid on after they heated it, the container's hot. Remember, some molecules have escaped. They seal the hole with a lid, and then the container is allowed to cool. So they're cooling it down, so the container is cooling, and when it's cooling, it collapses. It collapses according to this diagram. So it goes from being rigid to the can, whatever it's made of, say it could be aluminium, it gets crushed. So they want you to explain why the container collapses. So remember, you've already lost some molecules when it was heating, so you've got fewer molecules than before, although that's not on the mark scheme. They want you to mention, again through the kinetic theory, any 2 points from the 4 I've listed. As it cools, the molecules move with lower speed as opposed to the previous part of the question. So there will be fewer collisions per second. That's the point that underlined is the crucial point. This means less force than before. So there will be a lower pressure inside, yeah, because each molecule will produce less force. The collisions will be less forceful, okay? But the pressure outside the container does not change because it's not affected by what's happening in the can. So now you've got a pressure difference between the outside and the inside. So that produces that difference in pressure. That pressure difference causes a force strong enough to crush the material of the container. Okay. Often this can be shown by removing the gas from inside, so the pressure is reduced by removing molecules, and that also reduces the pressure. So there's two causes of microscopically reducing pressure. They have lower energy and there's fewer molecules. And both of those lead to fewer collisions per second, which is the crucial point. Question 10 is in an amusement park. It's the vertical drop ride. Okay, so if you've been brave enough to go in one of these, they're just going to let it free fall. The passengers sit here, securely fastened in with their whatever restrainer they've used. It's called the car. The vertical shaft is where the mechanism which allows it to fall safely down and loses potential energy at the top and converts it to kinetic energy. So it says the car is pulled to the top of the vertical shaft, and I've put by mechanical work being done. So there's a machine that does that, so that's mechanical work or energy transfer. Then released from rest, and I've put here that means U is 0. The initial velocity is 0. From rest, as you know, means not moving. The car then falls freely. That means under the action of gravity. There is no restriction on the acceleration. So that means they're saying it's a very smooth system, or theoretical. They're just assuming that the frictional forces are negligible. Okay, so it's because of force gravity, that automatically means that you know you've got to use G is 10, which I highlighted from at the beginning, that this is the value you use for GCSE. They want you to calculate the speed of the car when it has fallen a distance S of 18 meters. Okay, so they want you to calculate V. That's what you've got to do. So again, you're using V squared equals U squared plus 2AS, which I highlighted in the equations at the front. So this equation is given to you. You just got to know when to use it. So we know U, we know A, we know S. The only thing we don't know is V. So you basically just put all the numbers in, and if you can do the multiplication in a calculator, you'll find that V squared, don't forget this squared, the V squared is going to be equal to 360. You square root it, you'll get 18.8. Once again, most of the figures we're given is only 2 significant figures, so you can round it up to 2 significant figures. That's how accurately we can be sure of the answer. Okay, so remember we got the speed as 19 meters per second because they're going to use it in the next part where they want you to show that you know the formula for kinetic energy. Okay, so m is mass, v is speed, so I've put the letters to prove I know that m stands for mass, v stands for speed. Then I can use the symbols equation, which just saves me a bit of time than writing out the full words. Okay, that you just got to make sure that they know, if you put a symbols equation, that you know what the symbols stand for. So 1 mark for quoting it. So you get a lot of marks in this syllabus for just remembering your equations. Okay, the mass of the car and its passengers is 2.1 tons. A ton is 1,000 kilograms. They tell you that later on in the question. So it's 2,100 kilograms because that's what we've got to use in the equation, and they want you to calculate the kinetic energy using the formula that you had to quote before. And has fallen 18 meters. Yeah, when it's fallen 18 meters, remember we calculated that approximately that would end up with a speed of 19 meters per second in part A. You put the values in, so 2,100 for the mass, 19 from the previous part for the speed, multiplied, square, make sure you square it, you'll get 380,000, and you just have to write the answer down. They've given you the units already, yeah, and that gets you 2 marks because the equation you got a mark for in the earlier question. The next bit, the actual speed of the car, it says when it has fallen 18 meters, is actually lower than the value you calculated in part A. Okay, so it says describe the energy transfers, yeah? So this is a common energy question. You can do mathematically potential to kinetic is very common, which is what we've done. Occurring, so you've got to describe the energy transfers occurring from immediately before the car was released, where it had gravitational potential energy initially, to when the car had fallen the 18 meters that we calculated before, if it had no friction. So obviously they're now referring to the fact that, well, obviously there is some friction, so our calculation is overestimating the final speed. They want you to refer to energy stores, and they want you to refer to transfers in your answer. Okay, they want to see if you know the correct terminology. Okay, so the energy stores is from gravitational potential energy store to kinetic energy store. This type of transfer is called a mechanical transfer because work is done. Yeah, in this case, the work is actually done by gravity. Yeah, they may actually deliberately reduce the acceleration of the machine by having some friction, so it is less dangerous. So in the process, that friction, yeah, is also going to produce some heat. So then you say some of the energy, the gravitational potential energy, is transferred to heat or the thermal energy store. So heat, the correct term for it, is thermal store. And that's by the friction in the shaft. Yeah, so where the car moves down the shaft. So the heat is then transferred to the car, because obviously by conduction this can happen, or to the shaft. That's what I've tried to write there. I'm sorry, it's gone off the edge of the screen. And some of it will go to the surroundings, yeah, obviously just by conduction or radiation or whatever. The hotter objects will lose heat to colder objects. This type of energy transfer is by heating, yes, where there's a temperature difference. So it can also be by radiation. So that's another form of, as long as you've explained the change from one store to the other, both of them come gravitational potential energy, and then you know that there's different types of energy transfer mechanisms. So one is mechanical and the other is by heating. You'll get your marks. The next question, penultimate question of the paper, is about waves. This time it's not just uses of waves. They want you to draw a wavefront diagram with the direction of travel represented by what we would call a ray. So if this was a light ray, you would be able to see it reflect off a surface, but it's not. It's a water wave, but you can still represent all waves using the same vocabulary, wavefronts and a ray showing the direction of travel. So basically wavefronts are the view from above of what the waves would look like, and the direction of travel is like a thin line showing the motion towards the side of the boat. So the side of the boat is represented by this straight line, although boats probably are not usually straight. So then they reflect, the waves will reflect off the side of the boat in this angle. They want you to show that the angle of incidence, as we call it, and is always drawn to the normal. They've asked you to draw a normal, so that will give you a mark. Normals are normally drawn with dotted lines, broken lines, and then they want you to explain. Obviously you need to draw the normal at the point where the ray or the waves are hitting the boat in the diagram. So it's a way of representing waves. So that's going to be where the direction of travel, yeah, of waves meets the boat, and then it bounces off. And they should bounce off according to the law of reflection. The reflected ray or the reflected waves should bounce off at the same angle that they come in at, and again that this angle will be equal to the angle of incidence. Okay, they want you to measure the angle of incidence, and many students I saw were measuring the angle here because they'd forgotten that all angles are measured to the normal. Obviously that comes with revision. You need to make sure you revise all the details, and if you measure it accurately with the protractor, do remember that in this exam you do need to take a protractor in with you. It will be approximately 66 degrees. And then they want you to complete the diagram like I've shown you here. They want you to draw at least 3 wavefronts. They want you to show that the wavefronts are the same wavelength as they were before, because nothing's changed. It's still in the same water, so they're going at the same speed. So they're just as frequent. So you've got to have 3 parallel to each other to get 1 mark, in the correct position with the same wavelength, and at the correct angle of the reflection. That's how you get the 3 marks. So attention and detail is what gets you it. They then say the boat starts to move, creating its own waves on the surface of the water. So surface waters or water waves are transverse. They want you to describe the difference between transverse and longitudinal. And because this is a mock exam, I actually put together questions from 2 different papers, and therefore some of the concepts are repeated. So we've already done the question, I think, on this before. So they want you to explain exactly what I've written, so I'll let you read through it. You need to know the definition and the difference between a transverse wave and a longitudinal wave. Okay? So I'll let you stop the video if you want to copy it out. Going to the next page, it says the diagram 2 shows the boat moving towards an observer. Yeah, you'll notice that the wave fronts become compressed in the direction towards the observer as the boat is moving towards the observer. So the boat is catching up with its own waves, if you like, the water waves that it creates, the wake that it creates as it's passing through the water. So it disturbs the water, but it's also catching up with the waves. So it wants you to explain why the frequency of the water waves, measured from the observer's point of view, is larger than the frequency of the water waves created by the boat. So this is actually called the Doppler effect. You may have heard of it. So from the observer's perspective, the wavelength, or the distance between the wave fronts, as drawn in the circle here, they get smaller. Well, if the wave fronts get smaller, that means the wavelength is smaller. The speed of the waves hasn't changed, because the speed of waves only it depends on the medium, which is water, and the depth of the water. Well, we assume that's constant, and then you have to show that you can use the wave equation to show that if the wavelength, which is lambda, decreases, the frequency will go up. So if lambda goes down, frequency goes up, because they're inversely proportional. This is how you get the 3 marks, and that's the penultimate question. The question 12 is about a parachutist jumping out of a helicopter. It's hovering above the ground. Again, they want you to use the equation v squared equals u squared plus 2as. So we have to look for where it falls. So it's initially at rest. Obviously, when you jump out of the helicopter in the vertical sense, it was hovering. That means it wasn't moving up and down, so it was keeping its height. So when it jumps out, when the parachutist jumps out, initially it will be at rest, and then falls vertically downwards. That means that gravity, again, is the accelerating force. So you've got to use A as 10. And then it says calculate the speed of the parachutist after they have fallen through a distance of 1,300 meters. So they're telling you S is 1,300 meters. So we know S, we know A, obviously 2 is the number, and U is 0. So you just simply, the same as before, you put the numbers in. And this is good to practice in the mock, because this is the most difficult equation in studying of motion. Don't forget to square root it. You get the answers to more than the number of significant figures that you can accurately quote. So again, I rounded it up to 2 significant figures, because the data we're given here is 2 significant figures. We don't know gravity accurately. We only use it as 10. The accurate value is actually 9.81. So they only want you to roughly know the speed. Finally, it says when the parachutist is much nearer to the ground, the parachute opens. So opening the parachute is the issue that they want you to discuss here. If the parachute obviously slows down the motion. Explain the changes in speed. So this is an explanation, and they want you to use ideas about forces in your answers. So you must realize that if you don't mention the forces, you're not going to get the marks. So the first thing you could say is that you know what forces are involved. Well, 2 forces, involved. So as long as you know, if you mention that you know that they're weight and air resistance, that's 1 mark on its own. When the parachute opens, the air resistance, it suddenly becomes bigger than the weight because of the greater surface area. So it has more resistance to the air as it's falling through. This creates, I think that's a spelling mistake, net force upwards. I should have really written a resultant force upwards or an unbalanced force upwards, yes, because now the air resistance, which is against the falling motion, is greater than the weight. Remember, the weight never changes because it's the same parachutist, and therefore the accelerations is also upwards or negative or against the motion. As long as you are explaining the acceleration direction, you'll get a mark. If you just say acceleration or the word without explaining it, you're not going to get the mark. And then you could, for a fourth point, I say the air resistance decreases as the parachutist slows down, and eventually the forces become balanced again. Okay, so that's a common question in GCSE. And then this is the final part of the exam. It says it is observed that from when the parachute opens to just before the parachutist touches the ground, the gravitational potential energy and the kinetic energy, I'm mentioning the word store, I don't really like it, but that's the term that you have to use now, and the kinetic energy both decrease. So gravitational potential energy is decreasing, kinetic energy is both decreasing. Yet, obviously, energy is still conserved. You have to justify how can both potential energy and kinetic energy be decreasing, but the law of conservation of energy must still apply. That's what it's saying. They want you to explain how that can happen. Well, first of all, you've got to explain that you know the gravity must decrease with height loss, yeah? And if you can even put the equation down to show that you know it. It's the height difference. As the height is being lost, the energy is being lost. Kinetic energy, yeah, also decreases as it reduces the speed. The parachute reduces the speed of the parachutist. You can put the kinetic energy as half mv squared. Okay, so once you do that, you've shown already 2 marks that you got, and then you can say the frictional forces. I don't know why highlighter pen seems to have stopped working. Yeah. Anyway, so let's see if we can do something else. Let's just change the color and see what happens. Okay, so anyway, I can't get the highlighter to work. I don't know why. Maybe it's the video is too long. The frictional forces, air resistance does work against the person falling, yeah, the parachutist, which causes some of this thermal energy to be built up, to increase. So thermal energy will increase whenever there's any resistance, friction, etc. Remember, air resistance is a type of friction due to this, I've put it there, meaning due to the friction. Some of the heat is lost to the surroundings due to the temperature difference, and this can be by conduction, so just from molecule to molecule, basically giving up the kinetic energy from the hotter molecules on average to the colder molecules, or by radiation, which is just anything warmer radiates more heat, so thermal energy is being transferred. So these are 1, 2, 3, 4, 5, 6 ways of getting 3 marks, and that ends the second part of the video. This is the method using a PDF rather than a visualizer where you can see my handwriting. So let me know what you think if you like this method. I think the quality of the resolution is a bit higher this way, and please like and share it with your friends so we get more viewers. Once we get enough subscribers, we'll be able to keep the channel going. So we really need your support on this, otherwise it won't be worth our time. Thank you very much for watching, and that's it for now. See you in the next video.